Assalamu alaikum and welcome to the first lecture of digital signal processing. Digital means the finite set of values to represent the real world objects. Signal means the variables, things that vary with respect to anything independent variable, which could be time, space. In 2D images, we have in images we have 2D, and in 3D we have space. Pressure, sound compressions, magnetic deviations, or recording tapes are examples of some signals. The other definition of signal, we can say signals come from sensors. Any output of sensor can be taken as a signal. Next, processing. Transformation through algorithms and techniques convert signals from one form to the modified version of original signal to achieve the desirable objectives is called processing. Now, overall DSP is the mathematics algorithms used to manipulate signals after they have been controlled to digital form. Transmission storage devices, time domain analysis, and frequency domain analysis are some examples of DSP. In time domain and frequency domain analysis, we have filtering. Filtering includes FIR, finite impulse response, IIR, infinite impulse response, and adaptation. Next, we move to compression. Compression helps us to reduce the size of the data. Look into these three images. All of them are 300 into 400 pixels. First image, we have a simple house. In the second image, we have a man standing outside the house, and in third image, we have a sun in addition to these two objects. If we calculate the overall data of these three images, we can calculate it by multiplying it to the factor of 3 because all of them are of same size. We can get the overall data of all the three images by multiplying the single data of each image by 3 because all of them are of same size. We have 120,000 pixels of each image. We will multiply it by 3. We will have 360,000 pixels of all the three images. Now our task is to reduce the data size, and ultimately by reducing the data size we can reduce the speed. Let's suppose we have a channel of 1 kilobytes per second from source to destination. It means that to forward 360,000 pixels we will have to wait for 6 minutes, which is quite a long time. To reduce this time we have to compress the size of the data. We have different technique to reduce the size of the image. First of all, we will use the cutting technique. We have a house in first image, second image, and in third image. The house is repeated again in second and third image. The new thing in second image is the man standing outside the house. We will calculate the pixels of the man standing outside the house, and in third picture the sun above the house, and use the same things for the house and the man and house in third image. In this way we can reuse the pixels for the house in second image, and in third image we can also reuse the pixels for the man standing outside the house. So the image is now divided into 3 parts. To reduce the size 10 times, we will now move 1200 pixels of the first image, 150 into 100 pixels of the second image, and 150 to 100 images of the third pixels of the third image. This will help us to reduce the size of the image. The first image will take about 12 seconds, second image will take about 1.5 seconds, and same will go for the third image. The total we will have 15 seconds to transmit the data of all the three images from source to destination on a channel of 1 kilobytes per second. So we can conclude that by using the compression technique, we can reduce the size of the data and ultimately increase the speed of data transmission. Now we move to searching techniques. We have two types of searching techniques, that is linear search and binary search. Linear search means that we have a random data and we have to search a number out of it. We have to check all of the data until we find out the desired number. But in binary search, we have the sorted data from in ascending or descending order, which help us in quick search. From number, for example, we have a data from number 1 to 1000 and we have to search the number 468. We will find the midpoint of the data, which will be equal to 500. As 468 is less than 500, we will discard all the data after 500. Now we will have the data from 1 to 500. We will again find the midpoint, which is 250. As 460 is greater than 250, we will discard all the data from 1 to 250. Now we will again find the midpoint, and by this technique we can reach to our data 468 very quickly. Another example, we can search the data of 7 billion peoples of the world if we have it in a sorted order in 2 raised to power 9 attempts maximum. But if we do linear search, we have to check the data of every person in the world, which will be very difficult for us. But by using the binary search method, we can reach to that person very quickly. That's all for today. Please subscribe to my channel for more videos on DSP.